Vector calculus. So, viral emergency control, tactical operations, and response. Vector calculus or vector analysis is concerned with the differentiation and integration of vector fields, primarily in three-dimensional Euclidean space. It is used extensively in physics and engineering, especially in the description of electromagnetic fields, gravitational fields, and fluid flow. The vector differential operator, the symbol is known as del. The vector differential operator del is defined. Del is equal to dou by dou x into I vector plus dou by dou y into j vector plus dou by dou z into k vector, where I, j, k are unit vectors along the three rectangular axes ox, oy, and oz. Now, the gradient or slope of a scalar. Let pi of x comma y comma z be a scalar point function and continuously differentiable, then the vector del pi is equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z into pi. I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z is called the gradient of the function pi, and is written as grade pi, which is equal to del pi. Del is a vector differential operator. Del is equal to summation of I into dou by dou x. Summation of I is equal I into dou by dou x plus j into dou by dou y plus k into dou by dou z. Del pi is a vector whose three components are dou pi by dou x plus dou pi by dou y dou pi by dou z. If pi is a constant, then del pi is equal to 0. Then del pi is equal to 0. Now we see some two basic problems. If pi is equal to x comma y comma z, then del pi is nothing but the formula I into dou pi by dou x, I vector into dou pi by dou x plus j vector into dou pi by dou y plus k vector into dou pi by dou z. I into yz plus j into xz plus k into xy. Now dou by dou x of these pi xy z. Now partially derivating with respect to x means dou x by dou x is going to be 1, then yz answer. Similarly xz and xy. So the del pi is nothing but I vector into yz plus j vector into xz plus k vector into xy. If pi is equal to log of x square plus y square plus z square, then find del pi. Solution. Given pi is equal to log of x square plus y square plus z square, del pi is equal to I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. Now dou by dou x of log of x square plus y square plus z square. Now we are derivating partially with respect to x, that is 1 by x square plus y square plus z square into dou by dou x of, first we are partially derivating log, then function of function rule, x square plus y square plus z square is nothing but 2x. So 2x divided by x square plus y square plus z square into I vector. Similarly, for j vector and for k vector. That means partially derivating with respect to y and partially derivating with respect to z. Now, 2 divided by x square plus y square plus z square into 2 divided by x square plus y square plus z square into xi vector plus yj vector plus zk vector, which is nothing but 2 by r square. R square is nothing but x square plus y square plus z square into modulus of r vector. 2 by r square into r vector is the answer. Now, del of r power n, which is equal to n into r power n minus 2 r vector. Now, we are going to prove this one. So, we will find summation of I into dou by dou x of r power n. So, remaining for y and z, we will put similarly. So, r power n is nothing but n into r power n minus 1 into dou r by dou x. We know that r square is equal to x square plus y square plus z square. Now, partially derivating with respect to x, 2r into dou r by dou x is equal to 2x. So, 2 get cancelled. Dou r by dou x is equal to x by r. Okay. Now, n into r power n minus 1 x by r, n into r power n minus 2 into x. So, similarly for y and z, so summation of I vector, then summation of I vector, similarly j vector, k vector is nothing but n into r power n minus 2 into xi vector plus yj vector plus zk vector, which is n into r power n minus 2 into r vector. N into r power n minus 2 into r vector. Now, next problem. Find del of r. We know that r vector is equal to xi vector plus yj vector plus zk vector. R is equal to modulus of r vector, which is equal to x square plus y square plus z square. So, squaring on both sides, we will get r square is equal to x square plus y square plus z square. Partially derivating with respect to x and with respect to y and with respect to z. Now, dou r by dou x is equal to x by r, dou r by dou y is equal to y by r, dou r by dou z is equal to z by r. So, del is nothing but, okay, del is nothing but I into dou r by dou x plus j into dou r by dou y plus k into dou r by dou z. So, I vector into x by r plus j vector into y by r plus k vector into z by r. So, now r vector into xi vector plus yj vector plus zk vector, that is nothing but r vector divided by r. Directional derivative. So, the directional derivative formula is del pi dot a vector divided by modulus of a vector. Find the directional derivative of pi is equal to x square yz plus 4xz square at 1 comma minus 2 comma minus 1 in the direction of 2i vector minus j vector minus 2k vector. Now, solution. Given pi is equal to x square yz plus 4xz square and a vector is equal to 2i vector minus j vector minus 2k vector. Modulus of a vector is nothing but square root of 2 square plus minus 1 whole square plus minus 2 whole square, which is square root of 4 plus 1 plus 4, which is root 9, 3. Now, del pi. Del is nothing but I into dou by dou x plus j into dou by dou y plus k into dou by dou z. Now, del pi 2xyz plus 4z square. into I vector plus x square z into j vector plus x square y plus 8xz into k vector. Null pi at 1 comma minus 2 comma minus 1. So we are substituting that 1 minus 2 then minus 1, which is nothing but 4 into minus 1 the whole square. So minus of minus plus here 4 and 4, which is 8I vector. Then x square 1 square into what is that minus 1. Okay, 1 square into minus 1, that is minus j vector minus 10k vector. Therefore, the directional derivative null pi 8I vector minus j vector minus 10k vector dot a vector 2I vector minus j vector minus 2k vector divided by 3, which is equal to 8 into 2 16 plus 1 then plus 20 divided by 3, which is 37 divided by 3. So the directional derivative is equal to 37 by 3. Next, in what direction from 3 comma 1 comma minus 2 is the directional derivative of pi is equal to x square y square z power 4 maximum. Find also the magnitude of this maximum. Now, pi is equal to x square y square z power 4. Then del pi I into dou pi by dou x. Then j into dou pi by dou y plus k into dou pi by dou z. Now, dou by dou x of x square y square z power 4. That is 2x y square z power 4. That is the answer here we are having. Then partially derivating with respect to y means, so x square into 2y z power 4, which is 2x square y z power 4, that is here. Next, 4x square y square z power 3. Now, at the point 3 comma 1 comma minus 2, we are getting 96 I vector plus 288 j vector minus 288 k vector. Modulus of del pi is equal to root of 96 whole square plus 288 square minus of 288 square, which is root of 1,75,104. So at the maximum, the magnitude of this maximum is root of 1,75,104. Unit tangent vector. The formula for unit tangent vector is dr divided by dt divided by dt, the whole divided by modulus of dr divided by dt. First problem, find a unit tangent vector to the following surfaces at the specified points. X is equal to t square plus 1, y is equal to 4t minus 3, z is equal to 2t square minus 6t at t equal to 2. Now, we know that r vector is equal to xi vector plus yj vector plus zk vector. Now, r vector is equal to t square plus 1 into I vector plus 4t minus 3 into j vector plus 2t square minus 6t into k vector. Okay. Now, dr by dt, dr by dt. We are differentiating with respect to t. 2t into I vector, then 4 into j vector plus 4t minus 6 into k vector. Then dr by dt at the point t is equal to 2. Then substitute t is equal to 2 in the above equation. 2 into 2 I vector plus 4j vector plus 4 into 2 minus 6 into k vector. Now 4i vector plus 4j vector, then 8 minus 6, 2k vector. Modulus of dr vector divided by dt is equal to root of 16 plus 16 plus 4, which is root of 36, which is nothing but 6. Now, unit tangent vector, which is equal to 4i vector plus 4j vector plus 2k vector divided by 6, which is equal to 2i vector plus 2j vector plus k vector divided by 3. Next, normal derivative. A normal derivative is equal to del pi. Modulus of del pi is nothing, normal derivative. So already we have solved del pi. Here the modulus of del pi is nothing but normal derivative. First problem, find the normal derivative of pi is equal to xy plus yz plus zx at minus 1 comma 1 comma 1. Solution, given pi is equal to xy plus yz plus zx, then del pi I into dou by dou x of that pi, then j into dou by dou y of pi, k into dou by dou z of pi, I into y plus z plus j into x plus z plus k into y plus x. Del pi at the point minus 1 comma 1 comma 1 is equal to 2i vector plus 0j vector plus 0k vector, which is 2i vector. Now, modulus of del pi is equal to root 4, which is equal to 2. Unit normal vector. Unit normal vector n cap is equal to del pi divided by modulus of del pi. So find a unit normal vector to the surface. X square plus xy plus y square plus xyz at 1 comma minus 2 comma 1. Given pi is equal to x square plus xy plus y square plus xyz. Now del pi. So del pi means first we are partially derivating with respect to means. We will get 2x plus y plus yz. So that is the answer here we are having. Now, with respect to y means x plus 2y plus xz. This is the second one. With respect to z, only term is xy. Right. Now, del pi at 1 comma minus 2 comma 1. I vector into 2 minus 2 minus 2. J vector into 1 minus 4 plus 1. K vector into minus 2, that is minus 2i vector minus 2j vector minus 2k vector. Modulus of del pi is equal to root of 4 plus 4 plus 4, which is equal to root of 12, which is equal to 2 root 3. N cap is equal to minus 2i vector minus 2j vector minus 2k vector divided by 2 into root 3 minus 1 by root 3 into I plus j plus k. Next, second problem. Find the unit normal vector to the surface x square plus y square is equal to z at 1 comma minus 2 comma 5. Pi is equal to x square plus y square minus z. Then n cap is equal to del pi divided by modulus of del pi. So del pi is equal to I into dou pi by dou x. This is the formula. Del pi formula. Then we are finding dou by dou x of x square plus y square minus z, that is 2x into I vector, then I vector here, no, that. Then dou by dou y of j vector into x square plus y square minus z. That is 2y j vector, then minus of k vector, right? Minus of k vector. Del pi at 1 comma minus 2 comma 5 is equal to 2 into 1 I vector plus 2 into minus 2 j vector minus k vector. So 2 minus 4, okay, 2i vector minus 4j vector minus k vector. Modulus of del pi is equal to root of 2 square plus minus 4 whole square plus minus 1 the whole square, which is root of 4 plus 16 plus 1, root of 21. Therefore, n cap is equal to, n cap is equal to 2i vector minus 4j vector minus k vector divided by root of 21. Next, divergence and curl. Divergence. The scalar product of the operator del, the symbol del, and a given vector which gives a measure of the quantity of flux emanating from any point of the vector field or the rate of loss of mass, heat, and etc. from it. So, divergence of f is del dot f, which is equal to dou f1 divided by dou x plus dou f2 divided by dou y plus dou f3 divided by dou z. So, del dot f vector is a scalar quantity. It's a scalar quantity. Next, curl. The curl of a vector field is formally defined as the circulation density at each point of the field. Curl is equal to del cross f, del cross f. So, del is nothing but I into dou by dou x plus j into dou by dou y plus k into dou by dou z. Cross f vector f1, f2, f3. Okay, that is f1 I vector, f2 I vector, j vector, k vector. Now, okay, the del cross f is equal to I j k, dou by dou x, dou by dou y, dou by dou z, it f1, f2, f3. Now, first problem, prove that curl of grade pi is equal to 0. So, grade pi is nothing but del pi. We know the formula of del pi. I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. Curl of grade of pi is equal to del cross del pi. So, I, j, k, dou by dou x, dou by dou y, dou by dou z. We know this one. Del pi is dou pi by dou x, dou pi by dou y, dou pi by dou z. Now, normal determinant expansion, I vector into dou square pi divided by dou y, dou z minus of dou square pi divided by dou y, dou z. Then j vector into dou square pi by dou x, dou z minus dou square pi by dou x, dou z plus k vector into dou square pi by dou x, dou y minus dou square pi by dou x, dou y. So, see, all the terms are cancelling. Okay, so I into 0 plus j into 0 plus k into 0. Therefore, curl of grade pi is equal to 0. Curl of grade pi. Curl of grade pi is equal to 0, or del cross del pi is equal to 0. Del cross del pi is equal to 0. Next, second one. Find the curl f for the function f vector is equal to xy I vector plus yz j vector plus zx k vector. Given f vector is equal to xy into I vector plus yz into j vector plus zx into k vector. To prove curl f is equal to del cross f. So I into j in I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z. I vector into dou by dou y into zx minus dou by dou z into yz minus j vector into dou by dou x into zx minus dou by dou z into xy plus k vector into dou by dou x into yz minus dou by dou y into xy. I vector into, here we are not able to derivate with respect to y. Since z and x are constant in partial derivation, it is 0, then minus of z can be derivated with z. Okay, so here 0 minus y minus j vector into z minus 0 plus k vector into 0 minus x. So minus yi vector minus zj vector minus xk vector. Right. So the answer is minus of yi vector plus zj vector plus xk vector. Next. Determine the constant a so that the vector f vector is equal to x plus z into I vector plus 3x plus ay into j vector plus x minus 5z into k vector is such that its divergence is 0. Its divergence is 0. So divergence is 0 means del dot f is equal to 0. Del dot f is equal to 0. So dou by dou x of x plus z, dou by dou y of 3x plus ay plus dou by dou z of x minus z. So here 1 dou by dou x is 1, then dou by dou y of ay is 1a, dou by dou z of 5z is minus 5. So a minus 4 is equal to 0, therefore a is equal to 4. Next. Find the divergence of the vector field. A vector is equal to xyz into I vector, 3x square y into j vector plus xz square minus y square into k vector at the point 2, minus 1, 1. So del dot A vector, which is equal to dou by dou x of xyz plus dou by dou y of 3x square y plus dou by dou z of x z square minus y z square. So yz plus 3x square then plus 2xz minus y square. So at the point del dot A at the point 2 minus 1 1 which is equal to minus 1 into 1 plus 3 into 2 square plus 2 into 2 into 1 minus of minus 1 the whole square, minus of minus 1 the whole square, which is minus 1 plus 12 plus 4 minus 1 which is equal to 14, is equal to 14. That is 16 minus 2, which is equal to 14. Now, irrotational and solenoidal vector fields. Irrotational and solenoidal vector fields. First, solenoidal. If the divergence of a vector is 0 everywhere in a field, then the field is termed as solenoidal. Divergence means what? Del dot F is equal to 0. Then it is termed as solenoidal. Then it is termed as solenoidal. Solenoidal vector formula, del dot F is equal to 0. The solenoidal vector file V can be expressed as the curl of the another vector F vector. Divergence of curl F is equal to 0. Divergence of curl F is equal to 0. Now, irrotational. The curl of a vector is 0. Everywhere is a field. Then the field is termed as irrotational. That is cross product. Del cross F is equal to 0. Del cross F is equal to 0, which is irrotational formula. The irrotational field can be expressed as gradient of scalar point function. Curl of grade pi is equal to 0. Just now we have solved this one. Curl of grade pi is equal to 0. See here the proof. Yeah. Curl of, see, the curl of grade pi is equal to, curl of grade pi is equal to 0. So just now we have proved this one. Curl of grade pi is equal to 0. Now, see here. Yeah. Curl of grade pi is equal to 0. Now, we are going to solve some problems. First one, prove that f vector is equal to yz into I vector plus zx into j vector plus xy into k vector is irrotational. Now, solution. Given f vector is equal to yz I vector plus zx j vector plus xy k vector. So, we know the formula of irrotational. Del cross f is equal to 0. Now, I, j, k, then dou by dou x, dou by dou y, dou by dou z, yz, zx, xy. Now, I vector into, now it is the answer is x, with respect to z means x, minus j vector into partial derivative now. So, dou x by dou x of xy, answer is y. Here, with respect to z means we'll get y, then plus k vector into z minus z. Therefore, I into 0 minus j into 0 plus k into 0, which is answer is 0. Therefore, del cross f is equal to 0. Now we have proved the function f is irrotational. The function f is irrotational. Now, del cross f vector is equal to, so here what we have proved is shown here. Now next problem, prove that 3x square y into I vector plus yz minus 3x y square into j vector minus z square by 2 into k vector is solenoidal vector. Given f vector is equal to, now solenoidal means what we have to prove? We are supposed to prove del dot f is equal to 0. Del dot f is equal to 0. Dot product. Now del dot f is equal to 6xy plus z minus 6xy minus z. So the plus negative term and positive term get cancelled means we will get 0. Therefore, f is a solenoidal. Next, find alpha such that f vector is equal to 3x minus 2y plus z into I vector plus 4x plus alpha y minus z into j vector plus x minus y plus 2z into k vector is solenoidal. Solution. Given f vector is equal to 3x minus 2y plus z into I vector plus 4x plus alpha y minus z into j vector plus x minus y plus 2z into k vector. So also given del dot f is equal to 0. So also given del dot f is equal to 0 means the solenoidal is del dot f is equal to 0. Therefore, del dot f dou by dou x of 3x minus 2y plus z. Then dou by dou y of 4x plus alpha y minus z plus dou by dou z of x minus y plus 2z is equal to 0. So 3 plus alpha plus 2 is equal to 0. Therefore, alpha is equal to minus 5. Now we are going to solve the gate questions. So far we have seen the basics of the vector calculus. Now we are going to solve the gate questions. The first question, del cross P, where P is a vector, is equal to. So there are given four options. So del cross P, which is nothing but the formula. Del into del dot P minus del square P. See, it is a formula. Next one. Right. Yeah. The magnitude, okay, the magnitude of the gradient function f is equal to xy z cube at 1 comma 0 comma 2 is. So we are supposed to find the magnitude of the gradient. So gradient is nothing but del dot f. Here the function is given in the form of f. So del dot f. Del is nothing but I into dou by dou x plus j into dou by dou y plus k into dou by dou z. Dot x y z cube. X y z cube. Now we are going to derivate partially derivate with respect to x means, okay. So now we will get the answer is y z cube I vector plus x z cube j vector, then 3x y z square into k vector. So at the point 1 comma 0 comma 2. Now at the point 1 comma 0 comma 2, okay, see wherever we are having y terms we are going to get 0. So if this one also 0, this one is also going to be 0. Only the term is x z cube into j vector is going to get answer. That means 1 into 2 cube into j vector, which is nothing but 8j vector. So del dot f is equal to 8j vector. So the modulus of del dot f is equal to modulus of 8j, which is equal to 8. So the magnitude of the gradient is 8. So the C option is the correct answer. The C option is the correct answer. Next one. If V is differentiable vector function and f is a sufficient differentiable scalar function, then curl of f is equal to is a formula. Then grade f into v plus f into curl v. That means del cross fv is equal to del f into v plus f into del cross v. This is the formula. Okay. Therefore, grade f into v plus f into curl of v is the answer. A is the correct answer. Next. See the expression of curl grade f. Answer a vector of 0 magnitude. See curl of grade f. So grade f. Now listen, the curl of grade f. The same the gate question which we have solved in the introductions. The curl of grade f. See here. Curl of grade pi. Instead of f, here we are having pi. Now, we have proved this one. See, curl of grade pi is equal to 0. The same problem which was asked in the gate. Okay. And instead of pi, they have given f. See the proof? Same proof. Now, dou square, it is dou square printing mistake. So, dou square f by dou z, then all the terms are cancelling. Now, we are getting 0. Now, we are getting 0 here. Okay. Now, see, the temperature field in a body varies according to the equation T of x comma y is equal to x cube plus 4xy. The direction of the fastest variation in temperature at the point 1 comma 0 is given by. So, given T is equal to x cube plus 4xy. First, I am partially derivating this temperature with respect to x and with respect to y. So, dou T by dou x is equal to 3x square plus 4y. At the point 1 comma 0 is 3. Then dou T by dou y is 4x. At the point 1 comma 0 is equal to 4. The direction of the fastest variation in temperature at 1 comma 0 is given by 3i vector plus 4j vector, or 0.6i plus 0.8j, 0.xi and 0.8j. Okay, so the option is C. The C option is the correct answer. Okay, next, if the velocity vector in a two-dimensional flow field is given by V is equal to 2xy I vector plus 2y square minus x square into j vector. The vorticity vector curl V will be the del cross V is equal to ijk. Here they are not having k term, so they have taken as 0, 0. Now we are going to expand with respect to k. With respect to k means, so we have to eliminate this row and column. Then dou by dou x of 2y square minus x square, then minus of dou by dou y of 2xy. Right. Now k vector into minus 2x. This minus is here. Then minus 2x, which is nothing but k vector into minus 4x, which is equal to minus 4x k vector. Minus 4x k vector is the answer. So option D is the correct answer. Option D is the correct answer. Right. See, you no need to solve. You don't need to expand this one. Okay, straight away we do the partial derivation. Here we are derivating dou by dou x for 2y square minus x square, means here y square is the constant term. By eliminating that constant term, we will get the answer as 2x. Listen, this is 2x. Then here it is also minus 2x. Minus of this one is 2x. So minus 2x, one second, I will erase it. Okay, now, yeah, right. So this one is, yeah, 4x. Okay, that is, the answer is, okay, right. 2x this one. So minus 2x into k, that is equal to minus 4x into k. Right. So the next gate question. The divergence of vector r is equal to xi vector plus yj vector plus zk vector. So it is asked in the year 2001. 2001. Now, so the divergence del cross f, that is, so del dot f, okay, the del dot f is equal to dou by dou x into I vector plus dou by dou y into j vector plus dou by dou z into k vector, xi vector plus yj vector plus zk vector. So dou x by dou x is 1, dou y by dou y is equal to 1, dou z by dou z is equal to 1. The answer is 3. The option B is the correct answer. The option B is the correct answer. Now, listen. See, the vector field F vector is equal to xi vector minus yj vector, where I and j are the unit vector, is okay. Where I and j are the unit vector is divergence free but not irrotational. Then irrotational but divergence free and irrotational, divergence free and irrotational. Now del cross F is equal to, so I into divergence, okay. I dou by dou x into I vector, dou by dou y into j vector, dou by dou z into k vector dot xi vector minus yj vector. That is 1 minus 1, which is equal to 0. F is divergence free. F is divergence free. Then del cross F is equal to ijk. By expanding this determinant, we are going to get equal to 0. The F is irrotational vector. Therefore, it is divergence free and as well as irrotational. So the option C is the correct answer. Next, the divergence vector, the divergence of the vector x minus y into I vector, y minus x into j vector, plus x plus y z into k vector. Now, del dot F is equal to, so we will call it as F ma. Okay, we are checking that F. Or otherwise, straight away we can write that. What is that, sir? Once again. Okay, straight away we can write. We will check dou by dou x of x minus y plus dou by dou y of y minus x plus dou by dou z of x plus y plus z. Now, 1 plus 1 plus 1. So answer 1 plus 1 plus 1 is 3. So the D option is the correct answer. D option is the correct answer. Then the divergence of the vector field 3xz I vector 2xyj vector minus yz square into k vector at the point 1 comma 1 comma 1 is equal to, at the point 1 comma 1 comma 1 is equal to, so 3z plus 2x minus 2yz. So 3 into 1 z point. All the points are 1 1, no. So 3 into 1 plus 2 into 1, 2 into 1 into 1. So 3 plus 2 is 5. 5 minus 2, which is equal to 3, is the answer. So the option C is the correct answer here. Next, the vector flow field is given by V vector is equal to 2xy I vector minus x square z into j vector. The verticity vector at 1 comma 1 comma 1 is, see, already we have seen the same model. The curve V del cross V, which is equal to x square I vector plus k into minus 2xz minus 2x, which is I vector plus k vector into minus 2 at the point 1 comma 1 comma 1. So I minus 4k is the answer. I minus 4k is the answer. So the answer option D is the correct answer. I minus 4k is the answer. Okay, right. Now, the angle between two unit magnitude coplanars vectors P and Q are given here. See, the formula for the angle between two unit magnitude, that means cos theta is equal to P vector dot Q vector divided by modulus of P vector, then a modulus of Q vector, modulus of P vector into modulus of Q vector. Then we have to do the dot product of I with I, J with J, here that J with J, K with K is 0. Now we are doing the dot product, okay, and we are getting the answer as, okay, 0.707. Cos theta is nothing but 0.707. Therefore, theta is equal to 45 degree. We are getting 45 degree, right? So the area of the triangle formed by the tips of vectors A vector comma b vector and c vector is 1 by 2 into a minus b into a minus c vector modulus of. Okay, it is the formula. Then now in a flow fluid in the xy plane, the variation of velocity with the time t is given by v. V is equal to x square plus yt I vector. Then v vector is equal to x square plus y square into I vector. Right. The acceleration of the particle in the field occupying the point 1 comma 1 at time t equal to 1 will be, now v vector is equal to, x square plus yt into I vector. V is equal to x square plus yt at the point t is equal to 1, that is 2. Then partially derivating with respect to u and t, then dou u by dou x is equal to 2x, which is 2. Dou u by dou t is equal to y at 1. Then dou u by dou y is equal to t, which is equal to 1. Since we are having x and y, we are derivating partially with respect to x, y, and t. Then ax is equal to u into dou u by dou x plus b into dou u by dou y plus w into dou u by dou z plus dou u by dou t. The answer is 5i vector. The answer is 5i vector. Right. Now, the maximum value of the directional derivative. Directional derivative, which is nothing but del by dot a vector divided by modulus of a vector. Okay, the directional derivative. Okay, or directional derivative, no, right, one second. The directional derivative is modulus of del by, we can take modulus of. One second. Yeah. Yeah. Right. Now listen. Here the pi is given as 2x square plus 3y square plus 5z square at the point 1 comma 1 comma minus 1. Therefore, del pi is equal to 2x square means 4x I vector, then 6y j vector plus 10z k vector. So del pi at 1 comma 1 comma minus 1. 4i vector plus 6j vector minus 10k vector. So modulus of del pi 4 square plus 6 square plus minus 10 whole square, which is root of 152. Next, the directional derivative of the scalar function f of x comma y comma z is equal to x square plus 2y square plus z at the point p is equal to 1 comma 1 comma 2 in the direction of the vector a vector is equal to 3i vector minus 4j vector is, okay. So now we see the answer. See the directional derivative del pi dot n cap, del pi dot n cap. So del pi, from these del pi means what we have to write, that is 2x I vector plus 4y j vector plus k vector. Z is 1, no. Now substitute the point 1 comma 1 comma 2. Then 1 comma 1 comma 2 means 2i vector plus 4j vector plus k vector. See the answer here, 2i vector plus 4j vector plus k vector. Then a vector divided by modulus of a. So a vector divided by modulus of a. Modulus of a is nothing but 9 plus 4. That is, a is equal to 3i minus 4j. Then modulus of a is equal to root of 9 plus 16, which is equal to root of 25, that is 5. So here n cap is 1 by 5 into 3i vector minus 4j vector. See, a by modulus of a they have given here. Therefore, 1 by 5 into 6 minus 16. By doing the dot product, we are getting 2 into 3 is 6. 4 into 4 is 16 minus 16. 6 minus 16 is 1 by 5 into minus 10, which is equal to minus 2. The option B is the correct answer. Option B is the correct answer. See, where n cap is the unit vector in the direction of A, where n cap is the unit vector in the direction of A. But we have solved it by using that del pi dot A vector divided by modulus of A vector. So finally they have arrived this A by modulus of A by modulus of A. So you can use this formula and you can find the answer. Definitely we will get the answer as -2. -2. Next. Yeah. Next. If A and B are two arbitrary vectors with magnitude A and B, so A vector cross B vector, the whole square will be equal to, option A is the correct answer. So we know that A cross B is equal to modulus of A vector into modulus of B vector sin theta n cap. So AB into sin theta n cap. So modulus of A vector cross B vector whole square is nothing but A cross B whole square, which can be written as A square B square into sin theta n cap whole square. Here n cap is nothing but 1. So A square B square into 1 minus cos square theta. Sin square theta is 1 minus cos square theta. Then we are multiplying this A square B square here. A square B square minus of A square B square into cos square theta. Then, so we can write this AB into cos theta whole square. Then AB's cos theta can be written as modulus of A into modulus of B cos theta. Finally, the answer for this one is A vector dot B vector whole square. That is the final answer. A square B square minus of A vector dot B vector whole square. Once again, I'm repeating. So by using this formula, we are writing the answer. That is sine square is nothing but, okay, the sine square is nothing but, which is, yeah, yeah. Now, so n cap is 1. So sine square theta can be written as 1 minus cos square theta. And finally, we are getting this answer. Right. Now, for a scalar function, f of x comma y comma z, okay, the gradient at the point p of 1 comma 2 comma minus 1. So we have to solve gradient. Gradient is nothing but what? Del pi. So del pi at 1 comma 2 comma minus 1. So del pi is 2x into I vector plus 6y into j vector. Then what is that, sir? 4z into k vector. Now at the point 1 comma 2 comma minus 1. So 2 I vector plus 12 j vector minus 4 k vector is the answer. Okay, right. So the option B is correct answer, I think so. 2i vector plus 12j vector minus 4k vector. Okay, minus 4k vector. B is the option. Let me check now. Yeah, the correct answer is B. The correct answer is B. Okay, right. So the inner dot product of two vectors P and Q is 0. Then the angle between the two vectors is 90 degree. So inner two products is inner dot product of two vectors is 0 means the angle between the two vectors is 90 degree. Let me check. Yeah, C is the correct answer. Okay, C is the correct answer. Now, so the equation of, see, listen, if PQ are the 3 points having coordinates 3 comma minus 2 comma minus 1, 1 comma 3 comma 4, 2 comma 1 comma minus 2 in XYZ space, then the distance from point P to plane OQR, O being the origin of the coordinate system, is given by. Now the equation is this one: x minus x1, y minus y1, z minus z1. Then x2 minus x1, y2 minus y1, z2 minus z1. So here x1, y1 is z1, x2, y2 is z2, correspondingly x3, y3 is z3, and substituting all the points in this equation, We are getting that x minus 0, y minus 0, z minus 0. So by expanding this, we are getting 2x minus 2y plus z is equal to 0. Now, one distance from the point from P to the plane is, okay. So 2 into 3 minus 2 into minus 2. That is answer is 3 ma. The answer is 3. The answer is 3. What is that? We are substituting here that x, that is what the point. What is the point they have given? 3, 2, minus 1. 3, 2, minus 1. The first point we are substituting x, y, z. Okay, here, and we are finding the answer as 3. Okay. Now, so the function, the scalar function f of x comma y comma z is equal to x square plus 3y square plus 2z square. The directional derivative at the point p of 1 comma 2 comma minus 1 in the direction of a vector I minus j plus 2k is, okay. So the same as 18th question. So what we have solved in the 18th question, the directional derivative del pi dot n cap modulus of, or otherwise what I told, del pi dot a vector divided by modulus of a vector. So most probably the directional derivative they are asking in the GATE examinations. Okay, so you should be familiar about this directional derivative. Okay, so don't forget the formula del pi dot a vector divided by modulus of a vector. So the del pi is 2x into I vector 6y into j vector plus 4z into k vector. At the point 1 comma 2 comma minus 1. 2i vector, I think so, 12j vector minus 4k vector. Already we have solved this one, minus 4k vector. Here, a vector is equal to I minus j plus 2k a vector. Now, modulus of a vector is equal to square root of 1 plus 1 plus 4, which is root 6. Therefore, dot product 2 into 1 is 2, then 1 into minus 12 is minus 12, then 4 into minus 2 is minus 8. So the answer is root divided by root 6. So 20 minus 2 is minus 18 divided by root 6. I think so. The answer is B. Minus 3 into root 6. Minus 3 into root 6. Okay. Minus 3 into root 6. Next. Yeah. So for the scalar field, u is equal to x square divided by 2 plus y square divided by 3. Magnitude of the gradient at the point 1 comma 3 is, now del u. So dou by dou x into I vector plus dou by dou y into j vector into u. Xi vector plus 2 by 3 into yj vector. At the point 1 comma 3 is equal to I plus 2j vector. I plus 2j vector. Modulus of del u at the point 1 comma 3 is equal to root of 1 square plus 2 square, which is equal to root 5. This is equal to root 5. Right. If a vector r of t has a constant magnitude, then r vector dot dr by dt is equal to 0, r cross dr by dt is equal to 0, r dot r minus dr by dt, then r cross r is equal to dr by dt. So if a vector r of t has a constant magnitude, then the first answer is the correct answer. R vector dot the derivative of that r vector is equal to 0. See, r of t. So the vector is in the form of t. Okay. Now we are derivating and doing the dot product and getting this 0, and getting 0 means as a constant magnitude. When we get the constant magnitude, if we are doing that dot product means we will get constant magnitude. Then dot f is nothing but a scalar potential. Okay, scalar potential. Okay, the scalar potential. Therefore, The A option is the correct option. A option is the correct answer. Listen, R of t is nothing but here they have taken that. Listen, x of t into I vector plus y of t into j vector plus z of t into k vector. Now, R of t is equal to k, which is constant. K is equal to R of t is equal to k. That is x square into t plus y square into t plus z square into t, which is equal to constant. Now, yeah. Now we will see some more topics. Okay, some more problems. Okay, some more problems in this vector calculus. Okay, so now we will take this one. Okay, right. The area enclosed between the curves. The area enclosed between the curves. Y square is equal to 4x and x square is equal to 4y is. Now we have to find the answer. Now listen. So y square is equal to 4x and x square is equal to 4y. Now, both are parabolas. I'm taking a vertical strip. Now, y1 minus y2. So, y1 is nothing but, so y square. From this y square, y is equal to root of 4x. Or then, from this, I'm writing y. Y is equal to x square by 4. Now, the strip is, this is a vertical strip which was taken here. The strip is lies between, okay, lies between 0 to 4. 0 to 4. So therefore, 0 to 4, 2 into root x minus, okay, x square by 4 into dx. Now we are going to derivate with respect to x, okay, with respect to x, and substituting the upper limit, lower limit. Finally, and substituting the upper limit, lower limit, that is 2 into x power 3 by 2 divided by 3 by 2 minus 1 by 4 into x cube by 3, limit 0 to 4, limit 0 to 4, that is 4 by 3 into 4 into 2 minus 1 by 4 into 4 cube by 3. That is, what is that? 4 into 4, 16, 16 into 4, 32 by 3. Here, suppose we are cancelling, it means, yeah, 16 by 3. 16 by 3, which is nothing but 32 minus 16 divided by 3, which is 16 by 3 is the correct answer. 16 by 3 is the correct answer. Okay. Next. Right. See, for a function pi is equal to ax square y minus y cube, to represent the velocity potential of a fluid, del square pi should be equal to 0. So in this case, the value of a has to be, pi is nothing but ax square y minus y cube. Now we are finding that dou square pi by dou x square, that is second derivative of del. Okay, that is dou square pi by dou y square. Now del square pi is nothing but dou square pi by dou x square plus dou square pi by dou y square, which is 2ay minus 6y. Therefore, from this we can 2ay is equal to 6y, and y eliminated means we can write 2a is equal to 6, then a is equal to 6 by 2, which is nothing but 3. The answer is 3. Answer is 3. Next. Yeah. Yes. We will move on to next. Okay. A Stokes theorem is connects with the line and the surface integral. The Stokes theorem is connects with the line and the surface integral. Okay. See, the Gauss divergence theorem, surface integral into volume. Surface integral into volume. So Stokes theorem says that single integral to surface integral. Then divergence is double integral to triple integral. Then Green's single integral to double integral. Okay, right. Now listen. So we will see. Yeah. See, the value of integral function g of x comma y is equal to 4x cube plus 10 y power 4 along the straight line segment point 0 comma 0 to the point 1 comma 2 in the xy plane. So the equation of the line passing through 0 comma 0 and 1 comma 2 is y is equal to 2x. Okay, y minus y1 divided by y2 minus y1 is equal to x minus x1 divided by x2 minus x1. So by applying this one, we are going to get y is equal to 2x. Then given y of x comma y is equal to 4x cube minus plus 10 into y power 4. So which is nothing but 4x cube plus 160xy. So the point lies, x point is x coordinates lies between 0 to 1. Therefore, 4x cube plus 160 x power 4. On integrating and substituting upper limit, lower limit, we are going to get 33. We are going to get 33. Next. Yeah. So now I will summarize the topics. What are all the topics today we have seen? Okay. First we have studied del. Vector differential operator del. Del is nothing but I into dou by dou x plus j into dou by dou y plus k into dou by dou z. Then gradient or slope of a scalar. Slope of a scalar. So gradient, sometimes they may ask gradient and sometimes they will ask slope. Okay. So that is nothing but del pi. Del pi. Del pi. So del pi is equal to I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. Next, see, if pi is constant means we are not able to find the solution since the partial derivation of constant is going to be 0. So del pi is equal to 0. And then we have find del pi. Next, directional derivative. So the directional derivative is del pi dot a vector divided by modulus of a vector. Modulus of a vector. See, definitely you can expect a problem from these directional derivative. So most of the gate examinations they will ask the directional derivative. So they will ask the directional derivative problems. Next, after the directional derivative, we have seen that unit tangent vector. Unit tangent vector. Then after unit tangent vector, normal derivative. So normal derivative is modulus of del pi. Modulus of del pi. Then unit normal vector n cap is equal to del pi divided by modulus of del pi. Unit normal vector. Then divergence and curl. See, always you please remember divergence is nothing but del dot f ma. Curl is nothing but del cross f. So students, don't you always remember this? Don't forget that divergence is nothing but del dot f dot product. Curl is nothing but cross product. Okay. Next. So we have proved that curl of grade pi is equal to 0. So this is a great question. This is the gate question. Curl of grade pi. So there they have asked the curl of grade f. Curl of grade f. They asked us to prove is equal to 0. Okay. Next. And this one also important problem they have asked. If find curl of f vector is equal to xy into I vector plus yz into j vector plus zx into k vector. Okay. Now, so this one also important problem. So this is also finding constants. Okay, finding constants. Okay, determine the constant a alpha k. They will ask. Okay, such that its divergence is zero. Such that its divergence is zero. That means del dot f is equal to zero. Now, solenoidal and irrotational vector field. Solenoidal is nothing but dot product. Okay, del dot f is equal to zero. Divergence means del dot f dot product. Curl means cross product. Whereas solenoidal means del dot f is equal to zero. That is the formula. Okay, for irrotational, del cross f is equal to zero. Del cross f. See this. Del cross f is equal to zero is the formula. Okay. So, and here we are finding the alpha. So, almost we have covered all the topics. Okay. So, we prepare according to this. Okay, according to this. So, you will get good marks in the GATE examinations.